Okay, so why am I making such a big deal about the dimensions of the matrices that I'm multiplying and then the dimensions of the matrix that we get as a result? And here's why. In order for a matrix product AB to exist, the number of columns in matrix A must be equal to the number of rows in matrix B. If A is a matrix of M by N and B is a matrix N times P, so notice the rows in the first matrix have to be the same as the columns. I'm sorry, I just said that backwards. The columns in the first matrix must be equal to the rows in the second matrix. And if that's true, you are allowed to multiply. And when you do multiply, your resulting matrix will have the outer dimensions M times P. So it will have the number of rows from the first and the number of columns from the second. So if we go back and see, was that true in our earlier examples, notice that the inside numbers have to match, columns matches rows, and then that the outer values give us our final dimensions. And that is always true. So again here, our inner dimensions matched, giving us a resulting matrix of the outer matrix of the outer dimensions. So that's a quick way when you're looking at a problem to check, first of all, can I multiply these? Because sometimes the answer is no, I can't. And to let you know what your final answer should look like. Okay, so there are some laws of matrix multiplication that we should know. Multiplication follows the associative and the distributive laws. So I can multiply in any associative means that I can multiply not in any order, but in any grouping that I want. So if I have 3 matrices in a row and they all need multiplied together, I'm able to either multiply the first and then the second, the first two and then the third, or those last two and then back with the first. But notice the A, B, and C stay in the same order. Same thing with the distributive law. They have to stay in the same order. And the scalar multiple one just means I can apply that scalar to whichever matrix I want to and then multiply the matrices together. But there's a huge important note over here, which is that the commutative law of multiplication does not always hold, which means you cannot always reverse them. A times B does not always equal B times A. So in addition, that was true, but in multiplication, it may be true or may not be true. You can't just assume that that's true. Let's look at some more examples. I've given you 3 matrices. First, we want to give the dimensions of the defined products. Okay, so we want to check again, can we do these? And if so, what are their answers going to look like? So let's first give the dimensions of these matrices A, B, and C listed. A is a 3 by 2 matrix, 3 rows, 2 columns. B is a square 2 by 2. And C has 2 columns and 2 rows and 3 columns, so 2 by 3. Okay, so if I want to see if these exist, I have to check. If I'm going to do A times B, that means I'm taking a 3 by 2 multiplied by a 2 by 2. The middle numbers match. The columns in the first match the rows in the second, which means I can do this. And it means my result will be these outer dimensions of a 3 by 2. Can we do A times C? Well, A is that 3 by 2. C is a 2 by 3. The insides match, so yes, we can do it. The final result should be a 3 by 3 matrix. Excuse me. Can we do B times A? B is a 2 by 2. A is a 3 by 2. We have a mismatch inner dimensions, which means does not exist or no solution. So notice here, we can do A times B, we can do that, but we can't even do B times A. So we've definitely just shown that this commutative property doesn't always work, because not only are those two not equal, one of them doesn't even exist in this situation. Okay, B times C would be a 2 by 2 multiplied by a 2 by 3. So yes, we can do this with a final answer of a 2 by 3. C times A would be a 2 by 3 multiplied by a 3 by 2. So again, yes, we can, with an answer being a 2 by 2 matrix. And finally, C times B would be a 2 by 3 multiplied by a 2 by 2. Again, we have a mismatch inner dimension, so we cannot do that one. Does not exist or no solution. So let's just pick two that we actually can do and try them. If your answer is that there is no solution, you're done. If they ask you to do that, then you don't have to do anything further. Since we can calculate A times B, let's go ahead and do that though. So we want to take A, which is the column 3, 4, 1, and the next column 0, -2, 6. And we want to multiply that by B, which is first column -3, 5, second column 8, -1. This is the way I find the easiest to keep track of what you're doing, is to draw lines for the rows in the first matrix and draw a line separating the columns in the second matrix. Because what you're going to do is you're going to do a process of row by column, row by column, row by column in order to get these final solutions. Again, we should be aiming for, I'm going to make a really big matrix here, but we should have a 3 by 2 matrix when we're done. So we should have 2 columns and 3 rows. So I need entries all the way there. And if you know where you're headed, it can really help. So I need an entry here, 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 and here. Okay, so here's how we're going to do that. First, we're going to do the first row by the first column. So this first entry is going to be created by doing 3 times -3 plus 0 times 5. And now continue moving down and using every row in the first matrix with that same column. This first column makes our first column in our new matrix. So now I'm going to use row 2 with the same column. So I'm going to take 4 times -3 plus -2 times 5. And last row with that first column is 1 times -3 plus 6 times 5. To create my second column in my new matrix, I now need to repeat that process with all 3 rows, but with the second column this time. So we're going to take 3 times 8 plus 0 times -1, and that's the first entry. Move down to my next row and go across it and down that same second column. So 4 times 8 plus -2 times -2, -1, oh my goodness. Sorry, 4 times 8 plus -2 times -1. And lastly, 1 times 8 plus 6 times -1. And again, it really helps if you structure that out. Use color coding if you need to make sure that you don't lose track of what you're doing. I've demonstrated that it's very easy to just missee something and to accidentally write down the wrong value. Now I can simplify and then I'll be done. So what is 3 times negative 3 plus 0 times 5. You can do that in your calculator. Of course, you can do it on your paper or in your head. That's negative 9. 4 times negative 3 plus negative 2 times 5 is negative 22. 1 times negative 3 plus 6 times 5 is 27. 3 times 8 plus 0 times negative 1 is 24. 4 times 8 plus negative 2 times negative 1 is 34. 1 times 8 plus 6 times negative 1 is 2. And we've got our final 3 by 2 answer, and as long as I haven't misadded or multiplied, we should be good to go. Showing that middle step with that work, though, is a good way to get partial credit. Okay, now lastly, we want to multiply C by A. So I'm going to write those two down. C, first column is 0, 4. Second column is 2, negative 5. And third column is 9, 7. And we're multiplying that by A, which is first column 3, 4, 1. Second column 0, negative 2, 6. So again, we're going to go across the rows, down the columns. Because this one was a 2 by 3 and a 3 by 2, we know our final solution should be a 2 by 2. So I'm going to split this up. I need entries for here, 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 and here. Okay, and we're going to go do our across, down, repeat method. I'm going to go across the first row, down the first column. I'm not sure that I left myself enough room here, actually. I'm going to make this a little bit bigger. I think I need to make it wider in order to accommodate. Hopefully I have enough room here. Okay, so I want to take 0 times 3 plus 2 times 4 plus 9 times 1. Then drop down across the second row, still down that first column. 4 by 3 plus negative 5 times 4 plus 7 times 1. Now I've done both rows and I've exhausted that first column, so it's time to go back and do both rows again with the second column. So across the first row, but down the second column. 0 times 0 plus 2 times negative 2 plus 9 times 6. Wait, 9 times what number is that? I want to make sure I say it right. Yes, 6. Across the second row, down the second column. 4 times 0 plus negative 5 times negative 2 plus 7 times 6. Now, make those a lot prettier. We have 1, 2, 3, 4 entries to fill in. Just perform your calculations. First column should end up being a 17 and a negative 1, and your second column should end up being a 50 and a 52. And you can check that on your calculator along with me. And that's how you multiply matrices.